Okay, right, listen. So need of modulation we are discussing. So in the first factor, the reason behind the modulation is the size of the antenna or aerial. So if you want to send any signal, any wave into the space, the size of the antenna should at least the lambda by 4. Okay, now each antenna should have a size at least QUA quarter of the wavelength, quarter of the wavelength of the signal, quarter of the wavelength of the signal. Okay, this is the minimum condition. This is what the minimum condition. If you want to send any signal into the space, into the medium, the size of the antenna should be at least of 1/4 of its wavelength. 1/4 of its wavelength. Okay. Okay, Nana. That is the length of the antenna. Length of the antenna. Antenna, that is small l equals to what, Nana? Lambda by 4. Small l equals to what? Lambda by 4. Okay.
Okay,
Length of the
sir.
antenna equals to small l equals to 1, lambda by 4. Where what is lambda? What is lambda?
Wavelength of the signal, sir.
Wavelength.
Where lambda is what? Wavelength of transmitting signal.
Signal.
Wavelength of transmitting signal. Wavelength of what, Anna? Transmitting signal. Okay. So I will give a small explanation about this. I will explain about this. See here, I will give small explanation. 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 I will give a small example. For example, if an audio frequency, for example, if an audio frequency, for example, the frequency 15 hertz, we are sending 15 kilohertz. For example, let the electromagnetic wave of frequency we are sending, for example, 50 kilohertz, 15 kilohertz. Now we are going to calculate the length of the antenna. The length of the antenna. Okay, now. So now tell me what is the length of the antenna for any wave? The length of the antenna. The length of antenna. Antenna, that is small l equals to what? Lambda by 4. But we know what is wavelength, Nana? Wavelength lambda equals to what? C by frequency. Antenna. C by F. So here what is C, Nana? C is nothing but 3 into 10 power 8 meter per second by what is frequency, Nana? 15 kilohertz. 15 into 10 power 3 hertz. Hertz is nothing but what, Nana? Second inverse. Antenna. Second inverse. So here 3 ones are 3 5s are. That is 1/5 into 10 power 5 meter. 10 power 5 meter. That is 10/5 into 10 power 4 meter. 5 ones are 5 twos are. That is the length. The wavelength is how much, Nana? Wavelength lambda equals to 20,000 meters. 20,000 meters. Antena? అంతేనా? So
Yes, sir.
now
అవును.
the
Yes, sir.
length, the minimum length of the antenna, length of the antenna, the length of the antenna, which is given by lambda equals to what? L equals to lambda by 4. Lambda, how much we are getting, Nana? 20,000 meters we are getting by 4 is nothing but 5,000
5,000.
meters. 5,000 meters means what? Now 5 kilometers. 5 kilometers means what we can understood from this. What we can understood from this, if you want to send the frequency of 15 kilohertz, 15 kilohertz, what is the minimum length of the antenna? No, 5 kilometers. 5 kilometers is the minimum length of the antenna. Is it possible? Is it possible to construct 5 kilometers antenna?
No, sir.
Is it possible? No, it is practically impossible. Antenna?
Yes, sir.
It is practically impossible. It is practically impossible. So what we have to do, Nana? Now we have to increase the frequency of the signal. Okay, now we are going to increase the frequency of the signal. If you increase the frequency of the signal, what happens? Let us see. Okay, now if I increase the frequency of the signal, what happens? Let us see. For example, if the transmission frequency, if the transmission frequency were rise to 1 megahertz. 1 megahertz, that is the frequency is how much, Nana? 1 megahertz. 1 megahertz is how much, Nana? 10 power 6 hertz. Antena? 10 power 6 hertz. The frequency is 10 power 6 hertz. Now what is the wavelength, Nana? Tell me. What is the wavelength? Lambda. C equals nu lambda kadra. T by
Is equal to
F.
C by frequency.
Ah, 3 ante 3 into 10 power 8 meter per second by 10 power 6
10 to
second inverse.
heads.
That is 3 into 10 power 2. Antena? 3 into 10
Yes,
power 2.
sir.
That is 300 meters. 300 meters.
Meter.
Now tell me what is the
Length is
length of the
equal to-
antenna?
Small L is equal to
Length
lambda
of
by
the
4.
Lambda by
Lambda by
length of
4.
the antenna, L equals to lambda by 4.
lambda
Lambda is what? 300 by 4. That is
300
what?
meters by 4.
75 meters. 75 meters. Here we are getting 5 kilometers, but we are getting what? 75 meters, which is reasonable. Okay, na? It is
75 meters.
which is possible, right?
Yes,
Which is
sir.
possible to construct
Yes,
the
sir.
length antenna. Reasonable. So that
75 meters.
what happens, Anna? If you want to send the signal, we need high frequency waves. Antenna. If you increase the frequency, the length of the antenna will be decreases. That we can construct. Understood?
Yes,
Understood,
sir.
Anna?
Understood.
Yes,
How
sir.
to we increase the frequency of the signal? That is by doing modulation. That is superimposing the message signal over a carrier wave. What is carrier wave? It is a high frequency wave. It is a high frequency wave. Understood?
Yes, sir. Understood.
Okay. So this is what happened. Hence, there is a need of converting the information. So that is, you have to convert the low frequency signal into one high frequency signal by superimposing on a carrier wave. This is called modulation. Understood? Arthamainda nana?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Very good, very good. Next, next one. Indra Bhagita. Am I audible? ఏం వస్తుందిరా భయ్, ఏ పోతలేంది ఇది? Okay, right? Is it fine? Is it visible?
Yes, sir. Visible.
Yes, sir.
Next, the effective power radiated by antenna. The effective power radiated by antenna.
Antenna.
So here I will give you a small the power radiated from a linear antenna, from a linear antenna of length small l is of length small l is the effective power radiated. The power radiated by the linear antenna of length l is given by power P is proportional to L by lambda whole square. L by lambda whole square. This is the
Whole square.
power radiated by the linear antenna. Power radiated by the linear antenna. For high powers
Antenna.
needed. For high powers are needed for good transmission. Okay, na? The high powers are needed for good transmission of the signals. Okay, na? The high powers are needed for the good transmission of the signals. When how we are getting the high powers?
With a low wavelength.
Low wavelength means high frequency.
Oh,
Low wavelength is nothing but what? High frequency.
High frequency, sir.
As high powers are needed for
Good.
good transmission. And then
Yes, sir.
high powers are needed for good transmission. When it will happen, for the power should be high means what? Power should be high. High powers are required means we need from this expression wavelength should be very small. Wavelength should be very small. Wavelength should be small means what? We required high frequency waves. And then
High frequency.
high frequency
Yes, sir.
waves. High frequency waves.
Okay.
So that what happened for high frequency waves, we need to superimpose the message signal on the carrier wave. On the carrier wave. That is called modulation. That is called modulation. Understood? Arthamainda?
Yes, sir. Understood.
So this is what the second factor. So that's why we need to do one modulation. The first one is what? Length of the antenna. Second one is what?
Effective power.
The effective
Power
power radiated by the
Radiated
antenna.
by antenna.
For more powers, we need the less wavelength. As that the frequency, we need more frequency. Okay. Next to mixing up the signals. Next one is one mixing up the signals from different transmitters. This is what the next scenario. This is what the next scenario. So here what happens many people, when many people are talking at the same time. For example, so many people are talking at the same time. What happens we just cannot make out who is talking out. Who is who is talking out. For example, many people are talking at the same time. Can we understand their words?
No.
No,
sir.
we cannot understand their words. Similarly, when many transmitters are transmitting the same information simultaneously, what happens? They are get mixed up. So that we cannot
Yeah.
distinguish. We cannot find the difference between them. That's why what happens, Nana? So that's why the possible solution is in communication at high frequencies. The possible solution is what communication at high frequencies and a band of frequencies each transmitted. Okay, now so that what happens, Nana? If you want to send the same signal from different transmitters, we need to change their frequency. We need to change their frequency. That is what the main fact. If you want to change the frequency, what happens? We need to do modulation. We need to do what, Nana? Modulation. The final thing is mixing up signals from different transmitters. Mixing up signal from different transmitters. Whenever we are sending the same information from the different transmitters having same frequency, the signals will be mixed up. So that what happens? We need to change their frequency. We need to change their frequency. If you want to change their frequency, we need to modulate the message signal on different types of carrier waves. On different types of carrier waves. Understood?
Yes, sir.
So I already forwarded these notes. Please go through my notes. If you read these sentences 1 or 2 times, you understood. Okay, no problem. The final thing, just remember mixing up signals from different transmitters. Mixing up signals from different transmitters. Okay. These are the 3 things which needs the modulation. Which needs what, Nana? Modulation. Understood?